Today we're going to look at rules, tables and graphs. A rule is an equation with two or more variables, and a straight line graph will result from a linear rule. A linear rule has to have a special form and it will result in a linear graph. So for two variables, a linear rule often has y as the subject. So here we've got two examples. Y equals 2x plus 3. Y is the subject of this equation, it's over by itself. And y equals negative x plus 7. Y is by itself. Both of these rules are linear rules. So to graph a linear relationship, firstly you need to construct a table of values, finding a y value for each x value. So here we've got an example table of values here. I've chosen the x values semi-randomly. I've just made sure that I've got a negative value, 0 and some positive values. 5 is usually a good number to have, but you really, the minimum you need is 3 different values to show whether your relationship is linear or not. You can usually pick a linear relationship if there's with the other value, when you've got y as the subject with x as your other variable, it cannot have any squareds or any other variables attached to it. So x by itself will almost always be a linear relationship. So let's have a look at filling in this example table of values here for our linear rule here, y equals 2x minus 3. So for our first value for x, we can substitute negative 2 into our equation here and do 2 times negative 2, which is negative 4. Negative 4 minus 3 is negative 7. Negative 1 substituted in there will be negative 2 minus 3, which will be negative 5. Substituting in 0, it'll be 0 minus 3, which will be negative 3. Substituting in 1, it'll be 2 minus 3, which is negative 1. And substituting in 2, we'll have 4 minus 3, which is positive 1. So you can see this is, we could now plot these points, and that's our second step to graphing our linear relationship, plotting these points in the table onto a Cartesian plane, onto a graph. So here our first value that we would plot would be negative 2, 7. Okay, negative 2 for the x value, 7 for the y value. The next point we would plot would be negative 1, negative 5, etc., etc. Then once we've plotted all of these points on our table, we can rule a straight line through the points, and that will be a graph of our linear rule. Our first example, we're asked to construct a table for this rule and draw a graph of that rule. So once again, I've selected some values. I've selected some negative values, a 0 and some positive values. So here, substituting these into the equation, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. Negative 1, putting that into the equation, 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3, etc. And so just substituting in x values into our rule and getting what the y value is that comes out of it. So for this x value, we get that y value. For this x value, we get this y value, etc., etc., etc. Now we can plot these points on our graph. So our first point is negative 2, negative 5. So we've set up a set of axes. I've gone from about negative 6 to 3 because the y values here go from negative 5 to 3, so we can fit them all on there. Likewise, for my x values, I've made sure that I can fit those on my axis as well. So if I've got my first point, negative 2, negative 5, go negative 2 along the x-axis and negative 5 down, and I plot the point there. Next, negative 1, negative 3, I plot that point. 0, negative 1, plotting that point there. 1, 1, this point here, and 2, 3, this point here. Once I've done all that, the last step is to rule a straight line through all the points. Notice I have arrows on the ends. That's because the rule continues. It keeps going for all values of x and y. It's going to be true for all of those values. A second example, we need to decide if these 2 points lie on the graph of this rule, y equals 3x. So firstly, we could, if we wanted to, draw our graph and then plot the points and see if they lie on the line, but there is an easier way. We can just substitute our values in here, x value in, and see if we get the same y value. And if we do, it follows the rule and it must lie on the graph, on the line. So here, if we substitute our x coordinate for our first point, 1, 3 in, so our x coordinate's 1, so y equals 3x, y equals 3 times 1 here, and that equals 3, which is our y value, which is exactly what we want. That's the y coordinate, therefore it will lie on the line. So 1, 3 fits the rule and will lie on the graph. It's going to lie on that line. For our second point, let's substitute the x coordinate once again in, so the x coordinate is -2. We can substitute that into our rule. 3 times -2, that's -6. Now that's not equal to our y coordinate. Our y coordinate's -4. So this point here will lie off the line. It's not going to lie on the line. If the point was -2, -6, then it would follow the rule and it would lie on the line. So therefore, this point -2, -4 does not fit the rule and will not lie on the line or on the graph.